So I'm going to figure out my distances. How far was it from here to here? Positive 2. How far is it from here to here? Negative 5, right? I got that from my ordered pairs. Yeah, just the top one. Then can I find the third side? I do my x squared plus my y squared equals my r squared, which is still the same formula, a squared plus b squared equals c squared. We're just using our x's and y's to help us with directions. So you'd have 4 plus 25 equals r squared. Can you guys tell me what that's going to be, or do I need to do it step by step? Square root of 29, thank you. So the radius side of my triangle, or the hypotenuse side of my triangle, is the square root of 29. And then from there, I can just find my trig functions. So from my angle that I drew, the sine is the opposite over the hypotenuse, which is my y value over my x value. So it would be negative 5 over the square root of 29. You can punch that in your calculator, or this one's easy enough to do in your head, right? What's this one going to be? Yeah, over 29. So here's my sine value. Then I go find my cosine value. My cosine value is the adjacent over the hypotenuse, or if you want to think about it as your x over your r, it will be your 2 over the square root of 29. So when you rationalize that denominator, you have 2 square roots of 29 over 29. And then the tangent would be the adjacent over, the opposite over the adjacent. So negative 5 over 2, which is your y over your x value. And you really can just leave it like that. Don't change it to a negative 2.5. Okay, I want to bring something up here with you before we go on any further. Okay, if I just told you that the sine is the y value, the cosine is the x value, and the tangent is y over x, do I know which signs they should have on them according to which quadrant they're in? So tell me this over here. If we were talking about x's and y's, this would be positive in that quadrant, wouldn't it be? My x would be positive and my y would be positive. So that means my sine's going to be positive, my cosine's going to be positive, and guess what else is going to be positive? My tangent's going to be positive, because positive divided by a positive is a positive. You following me on that? In this quadrant, my x value is negative and my y value is positive, right? So is the sine going to be positive or negative? The sine is yeah, the sine is positive. What about the cosine? Negative. And the tangent's going to be negative, because it's a positive divided by a negative, right? The sine divided by the cosine. Okay. In this quadrant, I'm negative, right? Sine is negative, cosine is negative, but what's the tangent? Positive, because sine divided by cosine is positive. And then the last quadrant, this would be positive, negative, right? My x is positive, my y is negative. So my sine is negative, my cosine is positive, but my tangent's going to be negative. So if you're ever wondering about the signs, you can totally just think about the quadrants that it's in. So let's just check and see if it worked out right, because we're down here in quadrant 4. Was our sine negative? Yeah. Was our cosine positive? Yeah. And was our tangent negative? Yes. So we know we did the signs correctly on that by checking our little chart up at the top that we just drew. Okay, so not even really thinking about it, and you can just think about it that way if you don't want to put negatives when you're like, well, that's really only 5. and you could do it with 5 and then worry about your signs later. I like to do it with the signs on there. It makes it easier for me. All right, drawing the angle in this position, -6, 0. So I'm over -6 and I'm up 0. So this is actually my angle right here. Do you guys agree with me? I started here and I'm ending here. That's like a 180-degree angle. Are you following me on that? Right? We're on that axis for our angle. So tell me this. Can I draw a triangle? No. But I do have an x value and I do have a y value. And if I did x squared plus y squared equals r squared, could I find an r value? Sure I could, right? So let's do that. X squared plus y squared equals r squared. So we'd have -6 squared plus 0 squared. So what's my r value going to be then, are you saying? 6, right? So if I know x and I know y and I know r, can I use those rules that we just said to find sine? Do you remember that sine is y over r? So it's going to be 0 over 6, which is really just 0. You following me on that? The cosine is x over r, which would be -6 over 6, which is -1. And the tangent is y over x, which is 0 over -6, which is still 0. Okay? So we found all of our values still, even though we couldn't draw a triangle with that. Okay? And did I actually really need to solve for r? I mean, the only place it really made a difference was on the cosine, right? I mean, that would have been 0 no matter what, and that would have been 0 no matter what. Okay, so kind of looking at that. All right, next one, try it again. We're 0, -4 this time. So we're over 0 and we're down 4. Okay, now again, if this is my angle right here, can I draw a right triangle to the x-axis? No. So I'm going to use my x and my y's again. My x, my y. Can anybody tell me what r is going to be without even doing the formula? 4, +4, right? And then just plug it into your formula. Your sine is your y over your r. So -4 over 4, which is -1. Your cosine is your x over your r, which would be 0 over 4, which is still just 0. And the tangent would be your y over your x, so -4 over 0, which is, anybody know what that is? It's actually undefined. You can't divide by 0, so it's undefined. Okay. So even if you can't draw your triangle because your angle is on one of the axes, you can totally just do your formula still and use your x, y, and r values. Okay. This next section right here tells you what a reference angle is. That's actually what we've been doing, is finding the reference angles. We just didn't tell you that's what we were doing. So when you draw your angle, we had a reference angle right here. It's 60 degrees. It's the original angle. When we draw this angle, the 120-degree angle, do you remember when we drew our triangle, we drew it straight down like this, and we used that 60-degree angle for the reference to find our trig functions. So it's called a reference angle when we do that. Here we drew a 240-degree angle, but if we were going to draw our triangle up, we really only used the 60-degree angle to figure out what that was. So we really are using what we call a reference angle. A reference angle has to be between 0 and 90 degrees. Okay, it doesn't go over that. And that's because we're going to always reference it to the x-axis, which is going to make it an acute triangle, an acute right triangle there. So let's just see if we can find the reference angles for these. So 230 degrees. So we're starting here on the positive x-axis. This would be 90, 180, and then how far do you have to go after 180 to get to 230? You have to go 50 degrees. So if we were drawing our triangle, we would go up to this positive x-axis right here, and what would our reference angle be? 50 degrees. Now, can somebody find some math that would just find that for me? Like what did we subtract from 230 to get to 50? 180, because we drew our triangle to the axis that was called 180 degrees, right? So to find that, we went to the 180 degree axis, okay? So same thing here. Let's find our reference angle here. We're doing 11 pi 6. So what do I have to break my pieces into?
6.
Yeah, 6 on the top and 6 on the bottom, right? All right, so get your broken into 6 pieces, top and bottom. And how many of those pieces am I going to take to make my angle? Oh, yeah, 11 of them, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All but how many of them? I only left 1 of them, right? This is going to be my reference angle right here because I would draw my triangle up to that x-axis right there. You following me? So what's that reference angle going to be? How many pi pieces are left? 1 pi over 6. Okay, to find that reference angle. Can we do it again? That wasn't too bad, right? The reference angle is just the angle that's made with your angle you draw and the closest x-axis. It has to be between 0 and 90 degrees. So we're sketching 135, so we're starting here. This would be 90. How many more degrees do I need to get to 135? I'd have to go 45, right? This would be 90, that would be 45 to get 135. So to the closest x-axis, what's the angle going to be for my reference angle?
45.
Yeah, 45, because that's how many degrees are left right here for my reference angle, so 45 degrees. You guys following me how we find the reference angle? It's the angle we would draw in our triangle to solve for the sine, cosine, and tangent. Okay, one more, 4 pi thirds. This is over 1, so I have to use the top and the bottom of my coordinate plane, right? How many pieces am I breaking the top and the bottom into? 3 equal ones. So maybe here and there. That's not very good, but you're getting it, right? 3 equal pieces. There and maybe there. Not very good for 3 pieces, but how many of my pieces am I taking to make my angle? So 1, 2, 3, 4. Did I do that right? 1, 2, 3, 4. Right here, right? So how many pieces do I have? Now let's think about it to the closest x-axis. I did screw up, huh?
No, you go straight up.
Oh, I'm like, did I screw up? I don't know, maybe I did. You go straight up, so I'm looking for this angle right here. How many? It's 1 pi over 3. Because there's only 1 pi to get to here. Sometimes it's better to make sure that you show those as dotted lines so you can see that you broke it up into equal pieces. But the reference angle is 1 pi over 3. Does anybody know how I could have got that just using my calculator? I could have done 4 pi thirds, and I could have subtracted off this pi right here, right? Because that's the closest x-axis is pi. So 4 thirds pi minus pi gives you 1/3 pi. You could have just done it on your calculator.